My name is Pranav. I am from Institute of Aeronautical Engineering, also known as IARE, and today I am discussing one of the most interesting and everyone's favorite topic, nearest neighboring distance. So before starting, I want to thank my respected faculty that for giving this opportunity to present myself. Coming to the introduction, in crystal lattice, atoms are arranged in a regular, repeating pattern. Nearest neighboring distance, which is also referred as NND, it is known as the distance between an atom and its closest surrounding atoms. This is an important structural pattern that affects the density of the atom, the bond strength of the atom, the amount of the atom, the electrical and thermal properties. So basically, that is like a crystal. Uh, the atoms are arranged in a regular pattern. It is like they are arranged in like the seats in a theater of one row, like same distance between every seat in that manner. This parameter affects the density. It may increase the density of the atom, it may decrease it, also it may increase the bond strength, it may decrease the bond strength, also it may affect the high melting point and also low melting point. So what is nearest neighbor? Our nearest neighbor is the atom that lies at the minimum possible distance from a reference atom. These atoms share the strongest interatomic interactions. So, the atoms which are present really close to you is known as the nearest neighboring atom. These atoms individually share the interactions among them. Now, coming to the definition of nearest neighboring distance. The nearest neighboring distance is the distance between the center of two atoms neighboring distance like the it is like the distance between the center of the one atom to the center of the other atom which is adjacent and which is very nearer to it, and it is represented as dnn. Now coming to NND in different crystal structures, which means nearest neighboring distance in different crystal structures. So nearest neighboring distance, it varies from different previous lattice. So today we are going to discuss three important structures, which are simple cubic structure, face center structure, and body center structures. So starting with simple cubic structure. In the simple cubic structures, atoms touch the edges. The lattice parameter is constant, which is referred as A, and the nearest neighbors are like 6 atoms, and the formula for the simple cubic structure is also constant. So it is like a simple structure. Generally you take a cube like in which one atom is present on one corner, on one edge, and other atom is present on the other edge. Coming to the body centered structure, atoms touch along the body diagonal. The body diagonal length is taken as root 3a, which is like two atomic radii fit along half the diagonal. The formula for the body centered cubic structure with respect to nearest neighboring distance is root 3a divided by 2. The nearest neighboring atoms are in body centered cubic structure are 8. Now coming to the face centered cubic structure, here the atoms touch along the face diagonal. The face diagonal length is root 2a. And the formula for face-centered cubic structure with respect to nearest neighboring atom is 8 divided by root 2, and the nearest neighbors are 12 atoms. Now it is the concept we understood like that. uh, so basically the distance between the two close atoms is the nearest neighboring distance, and also the face center structure cubic structure, uh, which is like a formula part. Now coming to its importance, very few member know about its importance. It determines the atomic packing. It helps in calculating density. So the nearest neighboring distance affects the bond strength, which weakens the bond or the strong bond, and also the mechanical properties, like when the two atoms interact, their mechanical properties gets changed, and also the melting point, which uh, which may decrease the melting point or also increase the melting point. Also electric conduction and also thermal conductivity, such as the temperature effect. Now coming to the applications, so this nearest neighboring atom is used in material science, nanotechnology, which is like the study of very small particles, so which are sometimes which are even we cannot see through the microscope, uh, which we can take help of the nearest neighboring distance atoms. And also in semiconductor physics, in x-ray diffraction analysis, while taking x-ray in the hospitals, this topic is only used nearest neighboring distance of atoms. And also crystal modeling and simulations, the person who makes like crystal models or the scientists who do research on the crystals to study its nature, they study the nearest neighboring distance among atom, like how it behaves, what type of crystal it is, uh, what's the melting point of it, like that. Now coming to the factors that actually affect nearest neighboring distance, factors affecting is like, if this changes, then the nearest neighboring distance may get affected. So coming to the lattice constant, uh, larger the lattice constant, larger the nearest neighboring distance. So basically lattice constant like increases the distance between two neighboring atoms. And also we have discussed the simple cubic uh, structure, body centered cubic structure, face centered cubic structures, all have different nearest neighboring distance formula, which is also one of the most affecting part in nearest neighboring distance. And also the bonding type, whether like it is a covalent bond or metallic bond or ionic bond, it takes in the terms of nearest neighboring distance. So basically the normal type of bond which is seen in atom is different, and in the nearest neighboring distance, while comparing two atoms neighboring distance, that time the bonding type will be different. And also the fourth one which affects the nearest neighboring distance is temperature. When thermal expansion, when temperature increases, the nearest neighboring distance also increases. Now coming to the external pressure, uh, this pressure actually decreases the nearest neighboring distance. It brings, so the external pressure decreases the distance, it brings two atoms very closely to each other. So coming to the summary which we have studied is, we have read about nearest neighboring distance tells how close atoms are in a solid. It tells about what type of crystal structures, different crystal structures have different atomic arrangements. And also nearest neighboring distance affects physical properties like, density, strength, bond among those two atoms, the melting point. And also nearest neighboring distance helps in material design, in crystallography, in engineering, the scientists who do research on the crystals, like that. Coming to the conclusion, it helps in many material properties like density, strength, and conductivity. Different crystal structures place atoms at different distances. They affect their behavior, they influence their behavior. About knowing nearest neighbor distance is important in physics and also in material science engineering and also in crystallography. Overall, it provides a clear picture that how closely atoms are packed inside a crystal. Like previously I said, this helps in also helpful in nanotechnology, which is very hard to understand, and also the scientists who regularly do research on the crystals. Thank you.